Hey everybody, and welcome to our last activity walkthrough of the semester. It's been a long ride and I'm so proud of you all for making it here. It's been a great semester so far. Very happy with how everybody is doing. So just give yourself a pat on the back before we start this activity because you guys have really adapted very well to this crazy semester we've had. This is a two-part activity. I'm going to be doing both parts in this video, lesson 21 and 22 activities. Lesson 22 is pretty quick. 21, I think, has the brunt of the work you're going to be doing. So without further ado, let's get started. This is going to be a program that represents a deck of cards. You've got your deck of cards class that actually contains an array of card objects. And in a standard deck of cards, there's always 52 cards. So an array is pretty well suited to solving this problem because it has that size limit. You know, once we create it, a size 52 array, it can't be made smaller and it can't be made bigger. And then we can really easily pull our card objects out of that array. So first thing we're going to do is create an activity 21 and 22 project in Eclipse and import these files. So I'm just going to go ahead and download these files. We are going to be implementing the deck of cards interface. So we've got an interface specifying all the different methods that our deck of cards class is going to have. Add that .java on the end. We've got two enums, and notice these enums are defined in their own files, which will be nice. We don't have to do like the whole, what we did with our category. We're ready to do, you know, task.category. We'll be able to use those enum values right away. So first thing it wants us to do is create a card dealer class with a main method, and then create, of course, the project. So let's go ahead and create the new project. Let's create this card dealer class. I'm going to go ahead and check that public main method box so we get our main method generated. And I think that's everything for the getting started step. So part 1, we need to create a new class named card that's going to implement the comparable interface. So we're going to have a compare to method. Every card will have the following instance variables, going to have a rank and suit. They're both enum types, providing those enums we imported. Then we have to create a constructor that takes those parameters. So let's go ahead first and import all the classes we downloaded. Alright. And you'll see we have errors right now in our deck of card interface because it's saying card can't be resolved to a type. We haven't created a card class yet. And so that is now in this first bullet point here. Create a new class called card that implements comparable. So let's go ahead and just take it bullet point by bullet point. Now, if you want to implement an interface, you actually can type it out here in this box. You hit the add button, and we search for the interface. If you type in comparable, go ahead, hit OK, finish, add the unimplemented method, and you do have to put the card class in here instead of T. T stands for type. And I'm going to rename my parameter to be C. Now, it just puts O because that's the default parameter. You can name it whatever you want. I'm going to call it C for card. So we already got our compare to in there. Now we're ready to implement our instance variables. Every card will have the following instance variables, rank and suit. And notice we've got the rank and suit enums here. Got rank as the number on a card. So notice we have the name of the number along with the numerical value. Now, this is an enum with a constructor, which means that these enums have an instance variable, rank. So not only do we have the enum name to be like the name of the number, but we also have the rank, because like a jack, even though it doesn't have a number, it's basically an 11 because a jack is higher than a 10, but it's not a higher rank than a queen. And so you've got rank 11 there. You've got face value and all that stuff. Then you got the suits, the different suits of the cards, and these have the name of the suit along with an actual Unicode escape character that, when printed out, will actually print the little symbol for that suit of card. So it's a string, but this is actually an escape sequence to generate in the case of clubs, the little clover shape. Oh, I accidentally exited out a card. There we go. And remember, when you're creating instance variables of an enum, you just name it that enum type. So it's going to be suit, private, suit, and I'll just call it lowercase suit, and private, rank, rank. It's as simple as that. Make sure your instance variables are private. Now we're going to write a constructor that takes a suit and rank as parameters. So in our constructor, we're going to initialize these two instance variables here. So remember, constructor just has the name of the class, and now it's going to take in a suit and rank. And again, we can call these the same names as our instance variables. Remember, computer scientists are lazy. We don't like to be creative and think of different names for things. So because I named this suit and rank, we have a naming conflict. Because remember, these guys are defined outside the curly braces, so we can see our instance variables in the constructor. And it's important we do, because we need to be able to initialize them. So you have to use that this keyword to make sure you're referring to this suit, the suit of this card that's being initialized here, and setting equal to the suit that got passed in. So we have to use this operator to initialize those instance variables. So that's a constructor. We're going to write getter methods for rank and suit. So the getters are going to look like this. Now these are getters, so they return the instance variable. So for suit, it's going to return a suit. So make sure you have that as the return type. And get suit, all it's going to do, return suit. Now we don't have to use the this operator here because there's no naming conflict. Suit just refers to this suit up here. And same for the rank. Easy as that. Right, a get value method that returns the face value of the card's rank. Now, what is that face value? That's that number. The number in the rank. And I believe we're going to have this because it'll be important to be able to get that value so we can compare cards. And that's going to be an int because the type is int here. And rank has got a get face value method because notice this is a private instance variable. We can't go rank.rank. We have to go through the interface, the get face value method. Implement the compare to methods next. We're going to return 0 if the values are equal, -1 if the value of this card is less than the value of the other card, and 1 if the value of this card is greater than the value of the other card. So just simple comparison based on the face value. So if this dot get, and I'm going to just go off the rank instance variable. Actually, you know what? I'm going to do this dot get value. That'll be easier than saying this. We could go this dot rank dot get face value, but that kind of defeats the purpose of this get value method we defined. So if this get value is less than c dot get value, because remember c is also a card, we're going to return -1 because this card is less than. Else if this dot get value is greater than c dot get value, we know that this card is greater than, we're going to return 1. And then else, if it's not less than and it's not greater than, we know it's equal to, so we can just return 0 in there. Nice. That was easy. Implement the toString method to return a string in the format rank of suit. And this is really cool because suit and rank both have toString methods in them. And rank doesn't actually have a toString, but we're going to use the enum's name. So if you go to that example, it goes ace of spades, 3 of clubs. So we need to get the name of the face value, and then the actual toString of the suit, because it's going to go the name and the symbol. It's going to be pretty cool. And all we're going to do is do rank plus of, and then plus the suit. Simple of that as that, rank of suit. So it would be 3 of clubs, and it would be the name plus the symbol. Now, depending on your computer's text encoding, these Unicode symbols might not work, so you might, that's why we include the name in there as well. Nice. So part 2, we're already on our deck of cards class. So the deck of cards is going to contain and manage that array of 52 cards. So it's going to look like this, and so on, all the way up to index 51. Because remember, for 52 cards, we have indexes 0 to 51. So we're going to create a new class called deck of cards that implements the deck of cards interface. We're going to add those unimplemented methods now. And then the deck of cards class will have those instance variables. So let's go ahead and create our deck of cards class. And again, I'm going to add my interface through here. I'm going to implement the deck of cards interface. Go ahead and hit finish. And check it out. Those methods are already stubbed out for me, just returning the default values, null if it returns an object like card, 0 if it returns an int. So that's really helpful to have those already auto-generated for me. Deck of cards must have the following instance variables. A deck size. A standard deck is always 52 cards. When I hear the word always, I'm already thinking constant. An array of cards in the deck. Next card index. So I think we're ready to go and start doing this. So I'm going to do a private final int deck size equals 52. An array of cards in the deck. I'm going to have card, because remember, it's the to make an array, it's the name of the type that's going to be in the array, and then those square brackets. We're going to call this, let's just call it cards. Actually, I'm going to call it deck. And remember, we're going to declare it here because we're going to initialize it in our constructor. I only initialized my constant up here because it's a constant. So I know I can set it equal to 52 there. But the rest of my variables, I'm just going to declare here. Oop, make sure that's private. We don't want people grabbing our deck of cards and manipulating it. And we're going to have that next card index. This is what's going to help us draw the cards out. And I'm also just going to declare that here. Write a constructor that creates the new deck of cards. The constructor will need a nested loop to go over all combinations of suit and rank values to create a card for each of the 52 possibilities. So first of all, it didn't say anything about parameters, so I believe this constructor is just going to have no parameters, which is totally cool. So So there we go. Now, this is really cool. They give us this for each loop that's going to help us create a card with each suit and face value. We'll need a variable to keep track of where you're inserting the card in the array of cards. So we are going to need some type of counter variable because we have to be able to say cards at I equals a new card. Because remember, a for each loop doesn't have any kind of counter variable. So this is really cool. If you do enum type dot values, it actually gives you an array of all the values in that enum, which you can then iterate over. So remember, every time you go through the outer for each loop once, you go through the inner for each loop fully. So say we start on clubs, that's suit S. Now we go into the inner for loop, and we're going to create a card for every rank of clubs, all the way from, how do card ranks go? From 2 to ace of clubs. Then we go out onto the next suit, and it'll do the same. And that's how we're going to iterate through and create our deck of cards. Now, if you copy and paste code from Google Docs, weird things happen because I believe the text encodings are different. So better to just type it out here. I always like doing that. So suit.values gives you an array of all the different suit values. And just the same way, and now we're going to create cards, or I believe let's do deck. I think they refer to it as cards, so let's change this guy to cards. A new card of suit S and rank R. Now, notice the problem. This is why we need a counter variable. We have no way to reference our array index. So I do have to just create a little local variable here. I'm just going to call it I. And then every time through the for each loop, every time I create a new card, I'm going to go I++ to increment I will start at 0. So first time through it's index 0, last time through it's index 52. Write a toString method that will print all the cards in the deck. And we're going to test deck of cards is working by creating a new deck of cards in the main method called toString and verify it prints out all the cards in the deck. Now let's look through the program to see if there's a certain way they want us to print it out. I don't think there is, so I think we'll just do it on every line. So let's go down here and implement our toString. And let's just return a string with all the cards in our deck, each on a new line. So again, following that pattern we use a lot, where I just create an output string that starts out as an empty string. Now I'm going to iterate through all the cards in my cards array, and for each one, I'm just going to go output plus equals card, because that's going to call the cards toString plus \n. And just to kind of enforce, I don't think this is necessary, but just to make it look nice for order of operations in concatenation, I am going to do the C+n first, and then that gets added on to output. And apparently I spelled output wrong. And now we're just going to return output. Test that deck of cards is working by creating a new deck of cards in the main method in card dealer, call it toString. Nice. So let's do it. Remember, there's no constructor, so all we have to do is deck of cards, deck equals new deck of cards. So that's going to create and initialize our deck, and if we just print it out, that will call the toString. So let's try it. Uh-oh. No pointer section, deck of cards. And when it says deck of... Now, this is what's known as a stack trace. And it starts... The bottom is actually where it broke first. So we called card deal... In their main method, it broke on line 5. That's our constructor where we created our deck of cards. Deck of cards.init is otherwise known as the constructor. That broke on line 12, and that threw a null pointer exception. So let's go here, and we threw a null pointer exception. Now, this is something that happens to people a lot when we're first dealing with arrays. Well, we're setting the array index, right? Well, did we ever say cards equals new array of cards and give it that size? We didn't. And so this is what happens to people a lot, is they try to use their array and they forget to initialize it. Because remember, every index in an array of objects starts out as null. If you go to the slides, when you have an array of strings and you haven't initialized it yet, look, you've got null. So this would actually throw a null pointer exception here when you get this name2 length. So let's go ahead and initialize our array of cards first. So I'm going to do cards equals new card. And again, we put our deck size in here to give it that size 52. So now I think it'll be happy. Let's go back to card dealer. Boom. Check it out. All your clubs, all your diamonds, all your hearts, all your spades. There you go. Now we're going to go ahead and implement the shuffle method. So we got, again, just like our bubble sort, we've got some pseudocode here. And it's not a perfectly random shuffle, but it's pretty close. We're going to use a random number generator to come up with the indexes to swap. We're going to go through the list, swap I with some other random index in the list. So let's go ahead and implement this bad boy. Go ahead and delete that to do. And we're going to create a for each loop here. And let's actually go, we're going to need a random object, so let's go ahead and create it first. I'm going to have to import random. And we want to do that first so we're not recreating the random object every time we go through the loop, because it does take time to create objects. And so we're actually making our program more efficient by creating the random object first and using the same one for the whole shuffle algorithm. And again, we're starting at 0, going up to deck size, so deck size 52, so we're going to get the last index is going to be 51, which is exactly what we want. And we're going to go ahead and say j equals some random number between the length of deck of cards and 0. So we're going to go ran.nextInt, and remember, nextInt takes a boundary, and it'll return a number between 0 and this guy. Not inclusive, so we'll never get deck size. We'll get 0 through 51 as possibilities. And then we're going to swap I and j. Uh-oh. We haven't defined a swap method. So we're actually just going to go ahead and swap them ourselves. We're going to say card temp, because we have to create a temporary variable to save the value of I. So we're going to say card temp equals cards I. Now we're going to say cards I equals cards j, and then we'll say cards j equals temp, just like we did in our last swap algorithm. So we save the value of cards index at index I, so we save that reference. Then we set cards I equal to cards j, so we're swapping the references there. And then we set cards j equal to temp, because again, if we set it back to I, we just have 2 card j values. Nice. And then we reset next card index. So every time we shuffle, we're going to set next card index back to 0. So we're going to go ahead and test our shuffle method by shuffling deck of cards and printing it out. and we need to make sure that the cards are randomized. So let's go back to card dealer, and now let's do deck.shuffle first. This program's nice because we can really test it as we go. And let's make sure these guys are randomized. No errors, and that sure looks random to me. I'd say that's a fairly shuffled deck. No card sharks are going to be predicting our shuffle algorithm. So now we're going to go ahead and implement the draw method. This is going to simulate drawing a card from a deck of cards like you would in a true card game. So the draw method is going to draw one card from the top of the deck. And after 52 calls draw, the deck will be, quote, empty, and the method will return null. Now, this doesn't mean we're removing cards from the array. We're actually just moving our next card index. So every time we draw a card, we'll return the card at next card index, and then increment next card index. So if, for instance, our next card index was 5, we call the draw method. We're going to return the card at index 5, so 7 of diamonds is what that looks like, and then increment to next card index. Next time we call it, it'll return the card at index 6, and so on. So these are your dealt cards after next card index, and then the remaining cards are next card index to the end of the array. And simply moving next card index back to 0 will be so shuffling will actually reset your next card index. So if we shuffled this deck, it sets the next card index back to 0 and randomizes the order of our cards, so we're ready to play another game or whatever we're doing with it. So let's go ahead and implement the draw method. And notice if I erase this line to start working on my method, it's going to cause an error because it's going to say, hey, this method must return a result of type card. So returning null just is a placeholder because null is a valid reference for all objects because all objects in Java can have a null reference. So let's go ahead and check first that we have valid next card index, because if next card index is equal to deck size, so it's equal to 52, we know we don't have any more cards remaining. We're going to return null. Else, we're going to return the card at next card index. But then that's a problem because we can't increment next card index. How are we going to do this? Because in our constructor we set next card index. So how are we going to do this? Well, I think the easy thing, let's see if there's anything here that says it. So what I'm going to do is I want to increment next card index. So I'm going to say card equals, I'm going to say card drawn equals cards at next card index. Because I want to get the card and then I want to increment next card index. And then we'll return drawn. That way, next card index reflects the accurate value of the actual next card that will be returned at any point. So at any point in our program, we call draw. We haven't called drawn yet. Next card index always points to the next card that's going to be returned. So we save that card, then we increment, and then we return. So now we're going to test our draw method by drawing the first 3 cards off of the top of the deck. And so we know already, because we printed it, what cards are going to be in the deck. So if we save card, let's just call it card 1 equals deck deck.draw card2 equals deck.draw, and let's print both those cards out. Run that, and let's do a little print line here. So we have a break in the lines. So 6 of clubs, king of hearts, that was 1 and 2. And it looks like it's working. So awesome, everybody. So congrats on finishing part 1. We're going to move on and get started on part 2. And actually I was supposed to draw the first 3 cards, so let's add one more. And let's make sure it works here. 3 of spades, ace of clubs, king of spades. Nice. All right, well, let's get on with part 2. Alrighty, everybody. So we're gonna finish up our deck of cards now, and we're also going to create a little application game, that just draws cards, compares them, and you either win or you lose. You have a higher card or you don't. And so first, we're gonna go ahead, finish our deck of cards class, implement the num cards remaining and num cards dealt methods. Now, these are usually very, very hard methods for students to implement. They really struggle to understand what they're supposed to do, but implementing them actually isn't too bad. You see, what we're going to do is we're going to return an array containing the dealt cards that have already been dealt for, sorry, that's actually a dealt cards method. This is the num cards remaining and num cards dealt methods. So we need to return the number of dealt cards for num cards remaining, for num cards dealt, and the number of cards remaining for the number of cards remaining. Now, this is actually a lot easier than you think, because next card index points to the next card that's going to be dealt, right? So in this case, next card index is 5. That means that 5 cards have already been dealt because we start at 0. So if you're on next card index of 5, that means 0, 1, 2, 3, and 4 have already been dealt. 5 cards have been dealt. So let's go ahead and implement that one first. So all you have to do is return next card index. Simple as that. And think about it, if we're at the end of the array and we've dealt all of our cards, the next card index is going to be 52. That means we've dealt the whole deck. For num cards remaining, this one seems a little bit harder, so we have to figure out what's remaining. But what if we took deck size minus next card index? So if we've dealt 5 cards, that means there's 47 cards left. So what's 52 minus 5? 47. So to get the number of cards remaining, you just have to subtract next card index from deck size, because that's going to give you all of the remaining cards. And there you have it. So now we need to do something similar. We need to implement the dealt cards method. So we're going to return a new array, so we have to create a new array and copy the cards that have already been dealt into that array. So the next card index variable points to the index of the next card to be dealt, which implies that cards from index 0 to next card index -1 have already been dealt. For this activity, do not use arrays copy. We're going to use a for loop to create our copy. So first we need to create an array. So it's going to be an array of cards. I'm just going to call it dealt equals new card. And what size does it need to be? Well, next card index, remember, is the actual number of cards that have already been dealt. So all I have to do is create a next card index, because we know that'll fit exactly all the cards that have already been dealt. Now we need to use a for loop to copy them in. So we're going to say for and we can't use a for each loop because we don't want to iterate through all the cards, so we do have to use a standard for loop. And we're going to go up to, but not including next card index. So that's going to give us 0 to 2, next card index minus 1, which is all the cards that have been dealt. We're going to go dealt equals cards at I. Simple as that. And then, of course, we have to return dealt. Oh, and I forgot something important. Delt I equals cards I. I was setting the whole array equal to cards at I, which of course wasn't going to work. So let's go ahead and try and test this. Test delt cards by calling it in your card dealer class, print the cards in the returned array, and verify they're accurate. So let's go over to our card dealer. And we basically have to make sure that these 3 cards also get printed out here. So let's do a for each loop, and we're just going to go for card C in deck.delt cards. Whoa, that's not what I wanted. Nice. And we're just going to print out C. So let's try that. Jack clubs, 4 diamonds, king of diamonds. Boom! So we know the 3 cards we just dealt here got counted correctly by delt cards. Now we're going to implement the remaining cards method. This is the same thing, but for the cards that are remaining. So we need to loop from next card index, which is the first card that hasn't been dealt yet, all the way to the end of the deck. And this one, now that we've done dealt cards, I think it's going to be pretty easy for you. We're going to make another array of cards, call it remaining. And to really make it easy on me, I'm just going to call the num cards remaining. And you know what? I probably should have called num cards dealt to create my dealt cards array. And now we're going to loop again. And I is going to be less than deck size now. And I don't think I want to start at 0. I want to start at next card index, right? Because I want to get next card index, that's the next card that hasn't been dealt yet, all the way up to the end of the deck. Or say remaining at I equals cards at I. And of course return remaining. And now we're going to test remaining cards by calling it in card dealer and making sure it's accurate. So I'm going to do the same thing here. Copy that code, paste it, and instead I'm going to do remaining cards. And let's make sure it's accurate. Uh-oh. Array index out of bounds exception and remaining cards, line 67. Let's see what we did. Ooh. What did we do? Ah, do you see what the problem is? So the number of remaining cards isn't going to be of size 52. We actually need a separate counter that starts at 0 to keep track of our next card index. But let's think about it. Do we need a separate one? Or could we start at 0 and add next card index onto something? Let me riddle you this. Because I really don't want to create a separate counter variable if I can help it. So let's truly let's make I start at 0. And we only need to loop up to remaining dot length, right? Because that's how many cards we're going to have. So let's set remaining I equal to next card index plus I. Because the first time through, it's going to be 0, right? Oops, plus I, not 1. So this will be next card index plus 0, which would be next card index. And then it's just going to count up to the end of the array. So let's try that again now. Nice. So we dealt the first 3 cards, so we should get 4 of hearts through the end. Is that what we got for the cards remaining? Yes, it is. Look at that. Awesome. Very good. And now we're going to implement our card game. So we're going to create another driver class, another one with the main method, because card dealer was just to test our deck of cards class. Now we're going to create this war games class. And we're finally going to learn what our command line arguments were for. And I'll show you what I mean by that here in a second. And so war game is just going to take in a parameter when we run it, and I'll show you how to do that. And it's just going to draw a card for computer player 1, draw a card for computer player 2, and print out who won. So let's go down to the sample output. Simple as that. So we're finally going to learn what this means. The string args in your public static void main. I told you, literally in the last lesson, we're going to learn what this parameter means. And so let's go ahead and create that war games class. Gonna add that main method. So this args, let's try printing it out. So this arguments list is actually the command line arguments to your program. So I'm going to go ahead and I'm going to cd into this directory. So I believe this is teaching. Awesome. So there's my code. I'm going to compile my code. So what that string args is, it's the array of arguments to your program. And you pass arguments to your program by running Java wargames. And now we can pass as many arguments as we want. They're space separated. If I want to do an argument that's 2 words long, I have to put it in double quotes. So double quotes make an argument one whole argument, so you can have arguments with spaces. Otherwise, the arguments are space separated. And this is the list of arguments to the program. And, uh-oh, that didn't do too good. I need to print out S, not args. Let's try that again. Remember, I have to compile it. Let's try that again. There we go. And you see they all got printed out on a separate line, each argument. And this is really handy because it's a way of passing our program's input. But how do you do it in Eclipse? It's really easy. Click that drop-down arrow next to the Run button, go to Run Configurations. And you'll see the one for Wargames comes up. If you can't find it, these are all the different programs I've recently ran. And whatever your currently selected one is also your active run configuration. Go over to this Arguments tab. These are the program arguments. So I can go 1, 2, 3, hello, hello, world. Hit apply and hit run. And you can see it passed those arguments in. So that's another way of doing it in Eclipse. You don't have to go to the command line and run it, especially if you're on a Windows computer, you can't. So what we're going to do with war games is we're going to read in the number of rounds to play from the command line arguments. We got to validate the user enters the correct number. So really, what we have to do is verify that it is a number. So for this one, first we just got to read in the input from the user, and it says validate that the user enters the correct number of arguments. So for me, what that means is it can't be a negative number because we're going to go round, 0, round 1, etc. And then it has to be a number. They can't enter any kind of string. So I think we need to validate that it's not negative, and we also need to validate that it is a number. And so what I'm going to do is in my wargames.java, first I need to create an integer and declare it. I'm going to call it rounds. Now I need to try catch, because if you recall, trying to read in a trying to parse an integer out of a value with a string in it is going to cause an input mismatch exception, I believe. So let's import that guy. And now in here, we're going to attempt to read the variable in from args. So first of all, we need to make sure that args is of length 1. So you can't have more than 1. We're just accepting 1 argument. We're not accepting 2. So if args.length does not equal 1, we're going to print out a message to the user. Invalid number of arguments. And we're actually going to return from the main method. And we're going to return 1, which is like, oh, no, we're not. Sorry. I believe we can just return from the main method. So if you return from the main method, that's actually the same as ending your program. So else, now we need to try to parse our integer out. So we're going to go rounds equals integer dot parse int. We're going to pass it args 0. And then we need to check if rounds is less than 0. Well, and really, if rounds is less than 1, right? Because we need to have at least round. We're going to print out a message. Invalid number of rounds. And again, we'll return. Otherwise, rounds is going to be equal. And if we caught an input mismatch exception, we need to print out I'm just going to say same thing, invalid number of rounds. So all that just to parse our input correctly. Now, we need to go, for the number of rounds that we have, we need to draw a card for player 1, draw a card from player 2, and print out who won. So, we're going to go int I equals 0, and it starts at round 0. I is less than rounds. We're going to go I plus plus. So, we're going to print out round plus I plus dot dot dot, and we're going to go card 1 equals, well, first we have to create a deck of cards. We don't have a deck of cards. So let's do deck of cards. I'm going to call it deck actually. Deck.draw, card 2 equals deck.draw. And now we need to compare the two cards. So now we need to use the compare to method to compare our two cards. So if card 1 dot compare to card 2 is greater than 0, that means that player 1 wins. Else if card 1 dot compare to card 2 is less than 0, player 2 wins. Else, if it's not greater than, it's not less than, we know that it's a tie. And that's really all there is to it. Let's try it out. So invalid number of arguments, because we had that crazy run configuration in there. Let's try -1. Invalid number of rounds. Let's try something with a number. Number format exception, not input mismatch exception. So we need to catch the specific kind of exception that gets thrown. So let's try that again. Nice, invalid number of rounds. And let's try something realistic. Dang, player 2's on fire. Let's try it again. Uh-oh. Why is player 2 always winning? Have we shuffled our deck? Because if they're all sorted, the person drawing first is always going to lose. Now let's try it. So it's so funny because these programs really do model real life. Like if you don't shuffle a deck of cards in real life and you play this game, the person who draws first is always going to lose. Now look, it's pretty evenly matched. Well, I hope you enjoyed this last activity. I certainly did. And everybody, congrats again on finishing the semester out strong. I'm so proud of y'all. Happy coding.